Hey guys, we are getting into our first day of logarithmic functions. So this is probably something totally new to you. So we know we can evaluate 3 to the x equals 9, 3 to the x equals 27. We just know that, well, 3 squared is 9, so x is 2. 3 to the third is 27, so x would be 3. But what if we have 3 to the x equals 18? We know x would fall somewhere between 2 and 3, but right now we don't have a way to solve it. So you could do some guess and checking. Try 3 to the 2.5 in your calculator. Try, if that's too big, try 3 to the 2.3. And you can keep guessing and checking and getting closer and closer to that. But we mathematically have a way to do this. We need a way to do this. And so we use logarithms. So let b and y be positive numbers, and b is not equal to 1. So we can't have a base of 1. And the way that we read this statement right here is the log of y base b. So when we rewrite, we have b to the x equals y can be rewritten as x equals the log of y base b. So it allows us to solve for that x value that's missing. So let's first just practice rewriting in log form. So this would be x equals the log of 17 base 5. This would be x equals the log of 20 base 3. 0 would equal the log of 1 base 8. We can also go the other direction. So if we have it written in log form, we could rewrite it in exponential form. This would be 3 to the second is 9. This would be 4 to the sixth is z. This would be 5 to the negative 2 is 1 over 25. So we can go back and forth, rewrite it how we need to. Letter B here makes more sense to be written in exponential form because we can solve for z in that case. But it makes more sense, that first problem, to rewrite in log form, that first problem that we looked at on the previous page. So, a couple rules. If we have a log of 1 base b, that's always going to be equal to 0. I want you to think through this, because if we rewrote this in exponential form, that would be b to the 0, and we know anything to the 0 power is 1. So anytime you have a 1 there, log of 1, no matter what base it is, it's going to equal 0. Let's see if we can problem solve through this. We have b to some exponent is going to equal b. Well, that exponent then we know would have to be 1. So log of b base b is 1. All right, so evaluating. Let's see if we can try to manipulate this to see what we know here. So we have log of 64 base 4. We could rewrite as 4 to the x is equal to 64. Well, what would x have to be there? We know x would have to be 3. For part B, we have log of 0.125 base 2 equals x. So 2 to the x is equal to 0.125. Probably the easiest thing you can do here is to change that 0.125 into a fraction. So 0.125 is the same as 1/8. So 2 to the x equals 1/8. And then it should be a little more clear. 1/8 is the same as 2 to the negative 3. So 2 to the x would be 2 to the negative 3. So x would equal negative 3. Looking at C, we have 0.25 to the x is equal to 256. So 0.25 would be 1/4 to the x is equal to 256. So we know we're probably going to be dealing with a negative number, so 4 to what power would give you 256? 4 to the 4th power would be 256, so this would be 4 to the, or 1/4 to the negative 4 to make that move up there. And then this one we have 32 to the x would equal 2. Well, what base could we use to make that into a smaller number? 32 to the 1/5, so x would be 1/5 here. Alright, some common logs and natural logs. Common logs, if we have a base of 10, we don't have to write it. Just like if we have an exponent of 1, we don't have to write it. So log of x base 10 is just written as log of x. A natural log is when we have a base of e, and so we rewrite that as the natural log of x. And I use cursive there because I think it's easier to see ln, so you don't get confused by that, by it looking like a 1. So you will always see me write it that way. Use your calculator to evaluate. So if you haven't located the log button on your calculator, you'll want to do that. So log of 7, so that's a base 10, we don't have to write it. And you should get 0.845. If ever you are not getting these values when you plug them into your calculator, come in and see me and we'll go through it together. Natural log of 0.25, you should get negative 1.386. It's super important that you know how to type those in. Alright, so we are looking at inverse functions now. So b of x and log of x base b are inverse functions. When we compose them, they equal x. So here's our rule then. If we can get to b to the log of x base b, it goes down to just x. If we can get log of b to the x base b, it's just x. So we're going to use what we can to simplify some expressions on the next page. So I have log of 3 to the x base 3. When I see that, I know that everything in there will cancel out and we're left with just x. And then I have 4 to the log of x base 4. I know that everything in there cancels out except that x. Then I have log of 125 to the x base 5. Well, right now I can't do anything with it, but I can change that 125 to 5 to the 3rd power. So if I have 5 to the 3rd power times x, then all of that cancels and I'm left with just 3x when that simplifies. Then I have 10 to the log of 3. Notice there's nothing here as the base, so remember it's 10 to the log of 3 base 10. So when we have that base 10, that all cancels, and so that's just 3 when we simplify. Then I have the natural log of e to the 4th. Well, remember, natural log has a base of e that we don't have to write. So again, those bases being the same, we just end up with 4. Okay, guys, that is all I have for you today. We're going to spend more time on logs. If you have questions, feel free to come in and see me. Otherwise, I'll see you in class.